Okay, so here are two examples of these exercises using the sampling distribution for a sample mean worked out for you. I'll also put up PDFs, so if you don't want to watch this whole thing and listen to me and you just want to try it on your own and see how you do, you can just look at the answers. So first one here, a rental car company has noticed that the distribution, the number of cars customers put on the rental cars per day is right skewed. We already have a big heads up here. They have told us that our original distribution is not normal. The distribution has a mean of 60, so still has a mean of 60 and a standard deviation of 25. A random sample of 120 rental cars is selected. So they've also given us another big key here. They've given us a sample size. This is a big heads up that we're probably doing something along with the sample mean, because the sample mean questions are the only ones where we have a mean, a standard deviation, and a sample size. So the first question we get says, describe the sampling distribution, which means what the heck does this thing follow, of the average for a sample. So the average number of miles driven per day for a sample of 120 rental cars. So first things first, we're trying to talk about a sample mean, which is an X bar. And since this original distribution was right skewed, our sample mean can only follow an approximate normal by the central limit theorem. Our sample size is big enough, it is greater than or equal to 30, for us to have that approximate normality, but we could never have a true normal here because we didn't start out as a normal distribution. The mean of this, right, let's go ahead and calculate off to the side. The mean of a sample mean from our formula sheet is just the original mean. And the standard deviation of our sample mean, well, that's the original standard deviation divided by the square root of our sample size. So 25 divided by that square root of 120. So that's the only piece that we really have to calculate here, is figure out what the heck 25 divided by the square root of 120 is. So according to my calculator, we have our mean of 60 and our standard deviation is 2.2822. I'm just going to keep 4 decimal places because you guys know that's my favorite. This is similar to how this would be on an exam, right? Just like I said for part 6, I'm going to basically give you a little heads up that says, hey, what distribution are we using? And then a question that says, now that we know what distribution we're using, let's go ahead and calculate something, right? So the next question here says, what is the probability? So we're looking for an area under the curve that the mean number of miles driven per day for the sample of 120 cars is less than 54. So we are still talking about that sample mean, so we want to use all this information we calculated in the first part. Using our mean of 60, we want to know what is the probability that we would get 54 or less in this sample of 120, right? So looking for an area under the normal curve, this is just normal CDF. Since this goes off forever to the left, crap ton of 9s over here, right? Our negative infinity stand in, up to 54. And then here's the easy part for you guys on the test. Mean, standard deviation. They'll both be given to you in that first part of the problem. 60, 2.2822. We'll go ahead and calculate that and see exactly what we end up getting. I should have lights on in my house instead of squinting in the dark for what these answers are. All right. And 2.2822. According to my calculator, this probability is 0.0043. So a little less than 0.5% chance that the average of 120 cars would be less than 54. And again, this makes sense because as our sample size gets really large, it's harder and harder to get away values that are far away from that mean. So while 54 doesn't seem that far from 60, it really is when you take into account the standard deviation of 2.2822. All right, so let's look at the next question. Next question says, all right, again, let's find a probability. What is the probability that the total number of cars driven per day in the sample exceeds 7,400? Here's where things get crazy. So I recommend you pause the video, take a minute, see if you can figure out this tricky question on your own, how you would work with this. So either you figured it out or you didn't, either or you never even paused it. But the difference in this question is we're not talking about a mean, we're talking about a total. So if we go to draw our little sampling distribution, right, our normal, approximate normal curve centered at 60, it does not make sense to put 7,400, right? That's like somewhere way, like we do this and just go 700. That's not going to happen, right? That doesn't exist. So what we need to deal with is the fact that we have a total. We don't have our X bar like we did in the other one, right? We don't have a sample mean. But we can convert a total into a sample mean. How do you find a total? You add everything, or a sample mean. You add everything up and you divide by the number of things you have. So if we just take this and divide it by our sample size, you'll have your sample mean, right? All of the things added together divided by n. So whatever the heck that is. Looks like we have 61.6667, right? Really, 666 is repeated. So that is what we're interested in. Exceeding, the total number exceeds 7,400. That's the same thing as the sample mean exceeding 7,400. So we're talking about exceeding 61.6667. Exceeding would be shading off to the right. And again, this is just a normal CDF question. Starting at that 61.6667, going up to some reasonable stand-in for infinity, to our mean and our standard deviation. Again, one thing you may want to do on the test for this question is as soon as you figure out this piece here, the actual distribution, you may want to just come in and just get rid of that original sample mean, or the original mean and the original standard deviation, so that way you're not tempted to grab that 25 ever again. Okay, so I have no idea what this is. I will get it for you though, because I am super nice. I gotta type it in right though. Whew. This is exciting video watching, I'm sure. There are so many things on the little YouTube side that are just looking way more exciting than me. All right, so, all right. Let's do our last question here. Again, I strongly encourage you, pause the video, try this on your own before jumping in and just watching me do it. So this one's actually exactly like an exam question. No additional weird total piece to it. Okay, so hopefully you paused and are coming back. If you read through everything, you saw some important words. We had normal, we were given a mean, a standard deviation, and a sample size. Note that our sample size is a pitiful 10, but it doesn't matter because we started out normal, so we're still going to be normal. So when we go to describe the sampling distribution of our sample mean, X bar, in this case, since we are normal, will follow a true normal distribution, the mean of which is at 650, and the standard deviation, well, that's the one thing we actually have to calculate here. It's the original standard deviation of 120 divided by the square root of our n, which in this case is 10. So here we are. This is 37.9473. And then remember, once you get this, this is your key for every other problem. You could go ahead and just cross out all this stuff from the original. We don't need to have it. This is everything we need. So the next two questions say, what is the probability that a sample of 10 students spend a total of no more than 7,500? So again, we get that total thing. But we know how to deal with that now. We can change that total into an X bar, into a sample mean, which we know about, by just dividing by n. So basically, if the sample spends more than $7,500, that means on average, each person spent more than 750. So we are able to then use our nice little distribution centered at 650 that we found in the first part. We know we want to see of no more than 7,500, which is 750, and no more than would actually be this side, not what I was saying earlier. Clearly did not read my question. So that's what we're looking for. hopefully by now, after part 5 and part 6 and now part 7, you are incredibly bored of these normal CDF questions. Right? We should hopefully feel very confident in them. Again, just remember the biggest mistake on these is going to be using the original standard deviation instead of this calculated new standard deviation of 37, right? The standard deviation for a sample mean as opposed to for a single observation that we got going on here. So 5, 10, 9, 750, 650, and 37. Okay, provided I didn't type anything in here wrong. Looks like 99.58% chance that they spend a total of no more than $7,500. Okay. Last part here is slightly different, but again, nothing crazy or new for us. Second question, or third part here says, what is the value of a sample mean? So we're looking for a sample mean. Spent such that 14% of the means are more than this amount. So hopefully, okay, sample mean, I know some stuff about sample means. I know they come from a normal distribution centered at 650. Hopefully, this giving us a percentage is jogging your memory a little bit of part 5 in the last exam. That 14%, we know an area under the curve, right? We know, and since it says more than, that area under the curve, this 14%, is on the right side, right? And we are looking for a sample mean that would give us this. That's what we're looking for. So what calculator shortcut is this? It's inverse norm, right? We're doing the opposite. Instead of finding the probability from a given cutoff, we're using a given probability to find a cutoff. So we'd use inverse norm. Remember, for inverse norm, we feed it the left side probability. So since 14% is on the right, we need to go ahead and figure out that, 86% is on the left. So we'll put in that as our left side probability. And then again, just our mean and standard deviation from the first part of the problem. Like I said, on that next exam, I'm going to try to help you out by having that first part. And then we just type it in. We know it's got to be something more than 650 before we even get started based on our drawing. 0.86, 650, and 37. Looks like we get 690.9952, which you might as well write out with its units, $690. Oh, if I wanted to round this that has a reasonable amount of sense, I had to round it up. 100. So we'd expect a sample mean of 691 if we were going to get 14% more than that. So this is our true answer. So again, one of each type. Probably describe the distribution, find a probability, and inverse norm. That's what you can expect to see on the exam.